Very good evening to all the students. Welcome to Hydraulics and Hydraulic Machines class. Now we are dealing with Unit 5. Unit 5 consists of pumps. In that, we have centrifugal pumps and reciprocating pumps. So we started with the centrifugal pumps, and in today's lecture, let us focus on the components of centrifugal pump. What are the various components of a centrifugal pump? The various components of a centrifugal pump are: number one, impeller, a very, very important component of the centrifugal pump, impeller. Surrounding the impeller is the second component, it is casing, right? And then impeller, casing, number two. Number three is suction pipe. Number four is delivery pipe. So these are the four major components of a centrifugal pump. Once again, impeller, casing, third one is suction pipe, fourth one is delivery pipe. And if we see each component one after the other, impeller mainly is being rotated by the energy supplied from the motor. When the impeller is rotating, there are different types of impellers. When the impeller is rotating, the water which comes from the suction pipe comes in contact with the rotating impeller. Then the water or any fluid, in fact, is being pushed upwards under pressure. Pressure energy is imparted to the fluid. Thereby, the water or fluid is lifted from a lower elevation to a higher elevation. So, surrounding the impeller is casing. Casing has a hydraulic function. Its cross sectional area goes on increasing. It helps in converting the kinetic energy into pressure energy. There are different types of casings again here. It may be volute casing, vortex casing, or diffuser casing. But whatever is the casing, the main function of the casing is to convert the kinetic energy which is imparted to water by the impeller into pressure energy. And then how the water is supplied to the impeller, that is through the suction pipe. How the water is delivered to the required height, delivery pipe. So these are the fundamentally the four components. Let us see in detail the arrangement of a centrifugal pump, and then let us discuss about the components. So the topic for today's lecture is components of centrifugal pump. The four components of the centrifugal pump are: number one is the impeller, casing, suction pipe, delivery pipe. The arrangement I will show it to you for understanding purpose. At the center of the page, I am drawing first the shaft. Surrounding the shaft is the impeller. and over it, basically, we have the casing. So this is the basic thing, casing. And here we have the delivery valve. So we continue this pipe and it will be connected to the overhead tank. So this is the overhead tank. See how I am drawing also. So this is the water level in this overhead tank. If I see how the suction pipe goes from the center, I am showing it here, dotted lines. From here, this is the suction pipe, and the suction pipe goes into the sump. This is where the water is stored. So it is the ground level for which the centrifugal pump is kept, and this is what we call it as sump, and this pipe is called suction pipe, and this is called delivery pipe, and this is the delivery valve. And on this, basically, this is how the arrangement is. But here at the bottom of it, the suction pipe, we have an arrangement which we call it as, so this is footwall, this is strainer, right? On this, we will have vacuum gauge. On this, we have pressure gauge, right? So this part is called casing. This is what we call it as impeller. See the components, and it is how it will be rotating. The impeller is rotating like this. The impeller is being rotated by basically the energy coming from the motor, right? Because of its rotation, water is pushed up. From here, the water is being sucked actually from the suction pipe and it goes into the centrifugal pump. This is called as eye of the centrifugal pump, the central part. If I want to write the center line of the centrifugal pump, this is what we call it as the center line, right? So these are the various things to my knowledge. One is sump, overhead tank. Sump and overhead tank are such that from the sump we need to pump into the overhead tank. That's why we need a centrifugal pump. And for the centrifugal pump, I have shown the first component impeller. I have shown the second component casing, third component suction pipe, fourth component delivery pipe. All I have shown. A little bit extra what I can talk here is from the water level in the sump to the center line of the pump. This is called as suction head. HS is suction head. What is suction head? Suction head is nothing but from the water level in the sump to the center line of the pump. This is what we call it as this. Again, from the center line of the pump to the water level in the overhead tank, this is called as delivery head. This is called as delivery head. From the center line of the pump to the water level in the overhead tank. Now, this HS plus HD, that means suction head plus delivery head, is called static head. The summation is called static head. So here I stop this figure. If anybody asks you in the exam, centrifugal pump means this is the minimum that is expected from you. Components, drawing the impeller, drawing the casing, showing the suction pipe, showing the delivery pipe, connecting the delivery pipe to the overhead tank, connecting the suction pipe to the sump, and at the bottom of it we need to have a footwall and a strainer. The water is sucked actually the moment the motor first functioning is how motor is switched on by electrical energy. When electrical energy is given to the motor converts electrical energy into mechanical energy. That mechanical energy is given to the shaft. Now this impeller is connected to that shaft. So when the impeller is connected to the shaft, the impeller is forced to rotate by the shaft. When the impeller is rotating, the water is being sucked from the sump and coming to the center of the pump. There the water will be rotating, wherein the energy is imparted to water. With that high pressure energy, it leaves through the delivery pipe to the required height. So this is basic functioning of the centrifugal pump. Now let us think each component wise. The components wise, if I take it, first impeller, you take it. This is the main component. The impeller is the main component. It is actually the rotating element of the centrifugal pump. What an impeller consists of? It consists of a series of it consists of a series of backward curved vanes. This is the second thing. Third thing is, I already mentioned this impeller is mounted on the shaft and the impeller is being rotated by the external energy. That external energy is coming from the motor actually. And that energy which is imparted to the impeller, thereby it rotates the impeller. So this is the first thing. Second thing is there are three types of impellers. One is closed impeller. Second one is semi-open impeller. And third one is basically open impeller. In the case of open impeller, it looks like this. Suppose if you take this is the central component actually. So on this, how they look like, if you see, they like this series of curved veins, which are actually backward curved veins, are mounted on this. So like this, the veins are fixed. So this is called open impeller. You take it example of just a fan. Only thing is, in the case of fan, the blades are flat. If instead of flat, if you take them as a curved thing, actually, that is what the open impeller is. Then what is the second one is semi-open impeller. So in the case of semi-open impeller, there will be a base plate at the bottom. So that means the bottom of it is covered by a plate. So in the case of semi-open impeller, a base plate is arranged. A base plate is arranged. The figures I have already given you, please see. Arranged in case of a semi-open impeller. In the case of closed impeller, there will be both base plate and crown plate. Just there are nothing but circular plates. If the circular plate is fixed at the bottom of this open impeller, we call it as semi-open impeller. If we have one more at the top, then we call it as the closed impeller, are arranged in closed impeller. So that means the impeller vanes are covered with base plate in semi-open. The impeller vanes are covered with both crown plate and base plate. That is what the thing. So if suppose in the case of closed impeller, how it looks like, there will be only two plates, one above the other, but inside actually the veins are there. There will be openings actually. Through the openings, the water will be coming out. So in the case of the liquids, where they are clean and there is no debris, generally what you call it as for houses, the water supply things, we use closed impellers so that the water will be guided properly and naturally the efficiency will be higher. Whereas, suppose if you take it in the case of what you call it as viscous fluids and all, we may go for semi-open impellers. And in the case of, let us say, liquids such as sewage, we will go for open impeller. So this is our basic second regarding impeller. Then if I come to second component of it is casing. So in case of casing actually, which is surrounding the impeller, casing is an airtight chamber. It is an airtight chamber which surrounds the impeller, which surrounds the impeller. It is surrounding the impeller. There are different types of casing. The different types of casings are, number one is volute casing, second one is vortex casing, and third one is diffuser casing. Already I have given you the figures also in this basically lecture itself. But you see, in the case of any of these type of things, what will happen is the area of cross section gradually increases. It's a space, again, it's a spiral casing, but area of cross section gradually increases from the impeller to the from impeller to delivery pipe. Delivery pipe. This is the first thing. So what is the why gradually increasing? Why gradually increasing is this helps in, because of this, this helps in reduction of velocity, reduction of velocity, and increase of pressure head. For example, if you take first volute casing, there will be nothing as it is, whatever we have shown, that in the way, for example, this is the shaft position, and above this is the runner. Basically, if I take the runner also, these are the runner vanes, right? And above the runner, straight away the casing, gradually increasing. So if this is the case, this is what we call it as volute casing. So the only thing is, in the case of volute casing, normally what happens is, the water which comes out basically like this. Because in the case of centrifugal pumps, it is radially outward flow. When the water comes out of the impeller, naturally, when it is flowing through the casing, now what happens is, there will be number of what you call it as cross currents. Because of the cross currents, eddies will be more in this case. The eddies means cross currents will be more. Because of the eddies, more eddies, the loss of energy losses will be high. Losses will be high. So that is only the drawback in this. Otherwise, it is really a simple casing in which the energy conversion takes place, but some of the energy is lost in overcoming basically these eddies. So what we will do in the second one is, second one, if you take it in the case of vortex casing, if there is nothing extra, we do it, but we arrange the casing in such a way that there is a circular chamber left over above the runner. Suppose if this is the runner, if this is the runner, what we will do here is we leave some area. See how I am leaving it. It's not closer to it. We left some area and then with the casing is there. So that's why this, if you call it as here, there will be a circular chamber. A circular chamber is left over around the runner, and this is what we call it as the vortex chamber. Because of this vortex chamber, by the time they enter into the outer part of the casing, automatically the energy losses are reduced. So the efficiency of the pump increases. By having a specific vortex chamber, a vortex chamber is nothing but not anything additional. The casing is such that there will be more space is provided surrounding the impeller, not just directly coming out of the impeller and driven to the delivery pipe. There will be a circular portion, so that the water will be rotating there. Thereby, the eddies are being reduced, the cross currents are being arrested, and then it enters into the delivery pipe. The losses will be less. Whereas if you take the third part, actually, the diffuser casing, diffuser casing also very simple actually. If suppose this I take it, the runner part, for example, so these are the runner blades. Sorry, runner, I am talking nonsense. It is impeller. In the because the turbine terminology we should forget. The rotating element in the case of a pump is impeller. So here what will happen is we will have actually surrounding the impeller, we will have actually the guide blades. We'll have the guide blades, right? And then over it actually you have the casing, right? So this guide blades we have, that is what we call it as diffuser casing. Guide, because of the guide plates there will be control of the flow. The flow is directed, so naturally the efficiency will be high, but only the other problem is the pump cost goes on increasing. So these are the three things. One is volute casing, second one is a vortex chamber casing, and third one is a diffuser casing. So once the casings are over, the third component in the case of a centrifugal pump is what we call it as suction pipe. What is the suction pipe? Suction pipe is nothing but actually it is the pipe which connects, the pipe which connects, pipe which connects the center of the pump. The center of the pump is also called as the eye of the pump. The center of the pump or impeller to the sump. Sump means the source of water. From the center of the impeller to the sump, whatever pipe that is used is called as suction pipe. The liquid is lifted actually. Liquid is lifted from the sump. Please remember it. Again, remember the entire suction pipe is completely, it is airtight. Absolutely airtight. The pressure inside suction pipe is vacuum pressure, that is less than atmospheric pressure. So at the center of the pump, please note that it is negative pressure. It is suction pressure. So this is one of the very, very important things. At the bottom of the thing, there will be two things. One is footwall. Two components are there. One is footwall and the other one is strainer. The function of footwall is it is a non-return valve. See the wording, non-return valve. What do you mean by non-return valve? That means it allows water or liquid in only upward direction. That means one direction only, that too in upward direction. Right? Then what is the strainer component? Strainer is like a pot with holes, an iron pot, a mild steel iron pot connected to the suction pipe at the bottom. Actually, it is like a pot. It is only the main function of the strainer is to stop the debris. Otherwise, the impeller completely gets spoiled if any unwanted material enters into the pump. It gets damaged. To stop the debris, naturally, we need at the bottom of it, like a pot with holes, is connected. That is what the thing. So a suction pipe consists of this, but remember that the pressure in the suction pipe is always negative pressure. It is only sucking the water from the sump into the pump. And the last component is delivery pipe. Delivery pipe means a pipe whose pipe connecting the outlet of the pump to the overhead tank. This is what we call it as delivery pipe. The pressure in the delivery pipe is always greater. It will be more actual here. Under pressure only the water is supplied. So there will be delivery valve which regulates the flow in the delivery pipe and water will be supplied. So these are the four components of a centrifugal pump. Once again, what are the components? Impeller. Once we talk about the impeller, there are three types of impellers. One is the open type of impeller. The second one is semi-open type, and third one is closed impeller. Then afterwards, the second component is casing, where the energy transformation is taking place. So that is what we call it as volute casing, vortex casing, diffuser casing, and then the pipe which is supplying water from the sump to the center of the pump is called as suction pipe. And in the suction pipe, the pressure is negative pressure. It sucks the water from the sump actually. And the next one, the pipe which connects the outlet of the pump to the overhead tank is called as delivery pipe. So these are the four components. Here we stop this lecture and let us see in the next lecture the work done by the centrifugal pump. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.